Hi, how's it going? My name is Carl Diaz with the Learning Resources Center, and this is part 3 of the torque video. So let's get going. So we've solved these two. Again, go back and watch the videos for these because you need to know how they're solved and understand how we're using torque as a tool. This is just, again, probably a more simple problem. We could have started with this one, but just keep in mind there's other ways to do things, or there's simple problems and complicated problems. These are definitely probably the most complicated problems you'll deal with in this class here. And the hardest problems you'll probably solve. This is, again, the same type of problem, but it's a little bit more straightforward. So what we have is a dude, he's standing on this plank. I know his legs aren't all touching, but he is standing on it, okay? And it's being held up by these two strings, right? So there's two strings he's standing on a plank, and there's two ropes tied to something that are holding this thing up. Okay, so we know the tension is always up, right? It follows the rope. We know that the guy's having weight down and the ladder has weight down. So that's our free body diagram. Okay, tension's up, T2 and T1 are up, right? M1G is down and M2G is down. Again, you can always just blindly draw free body diagrams. That's what we did over here, is blindly draw free body diagrams. You can blindly draw free body diagrams. It's up to you, okay? So I would always suggest to do it that way, though, just to keep in mind. So we can see that and the question's telling us that we don't know these two tensions. I apologize about that. We don't know these two tensions. So they want to know. They're asking, what's the tension, what's T1 and T2? All right, and we know, you may be saying, aren't they equal? Can I just find them to be equal? No, because we know that since this guy's standing closer to T2, T2's having to hold up a little bit more than T1, right? It's doing a little bit more work because there's a little bit more force applied to this tension than this one. So keep that in mind because it's closer. So they're not equal. We gotta solve for them both separately. So here again, you can say, well, how in the heck do I do that? Right? We definitely know mathematically if I have two unknowns, I'm definitely going to need two equations. But you might say, well, how do I start this? Can't I just start with Newton laws? I know Newton laws help me solve for stuff, and you certainly can, right? That's why I don't have, these were numbered in terms of steps. This one isn't, because it's up to you. I want you to think about this in the way that you're comfortable thinking, all right? So let's say you want to start with Newton laws. I know I started with torque up here, but let's say you want to start with Newton laws. This is me knowing what to do, right? Let's say you look at this and say, hey, I like Newton laws, they're easy. Maybe I can do this with Newton laws. So you do, all the forces are in the Y. Mg's down, tensions are up, but they're all in the Y direction, either positive or negative. Right? So we want to write that equation, right? T2 is positive, right? Minus Mg1 because it's down, minus M2G because it's down, it's in the negative Y direction, plus T1 because T1's in the positive, right? These signs are coming from the direction of the vector, and this is in equilibrium, it's not moving, so it's balanced, equals to 0, right? And then we say, hey, well, here we go. Like I have a choice here, right? I can either solve for T2 or T1, but the thing that you're saying and the thing that we kind of knew before we started this and we did state is that I have two unknowns. One equation isn't going to do the job, right? But what you can say here is that you can say, hey, if I know T1, then what do you know? Then you know T2. Right? So then you go into your toolbox, open up your toolbox, and you search through it, and you say, hey, I know torque. This thing isn't spinning, but I know torque has force in it. It's another equation I can write, right? So I can always write two Newton equations, sum of forces in the X, sum of forces in the Y, and a torque equation if I need to describe forces, because I know forces in all those equations. Forces in the Newton equations in terms of linear motion, and forces in our torque equations. So if I need another force, you need to start thinking, hey, torque is a tool, all right? It's just not solving for something rotating, all right? We have to look at the object rotating in order to utilize torque, but the thing doesn't have to be rotating. This thing isn't rotating, but we can imagine if we cut like T2, T1 over here, that this thing would spin like this around T2, right? Cutting T1 would let this drop and it would rotate. So it tells us there's some rotation here, which means, hey, we can use torque because we have an idea of how this is going to rotate to utilize that idea. So everything's perpendicular here. That's something to know, that the forces are all perpendicular to the surface. They're not at any angles. And when we know that, then we know we can just use this equation, right? Torque times RF. Every time you can just write it. You don't have to worry about lever arms, right? That's why you want things perpendicular to the surface, so that you can just do torque like this and not have to find lever arms and go through all that work. So this is the torque that we need to write for any of these forces that we have here. We just have to decide which one we want to solve for. So we said, hey, if we know T1, we can get T2. So that means I'm just going to say, let's find an equation for T1, right? Let's solve torque for T1 because I need that. Let's use torque to find T1, right? And I know that the way I have this drawn, I can put my axis of rotation anywhere, but I want to place my axis of rotation where I can eliminate one of the variables that I don't need or want, right? We know the mass of the dude, we know the mass of the ladder, right? But we don't know these two tensions, so that means I want to put my axis of rotation at this T2 because I can ignore it. There's no torque there when I do that. And I know these values, and I don't know that one, but I can use these two to find that. I know these things by all the things we've done in this class, right? So I want to place my axis of rotation here so that I can ignore T2 in terms of my torque equation. I want to write three torque equations, one for the dude, one for the plank. I don't know why I called that L, but the plank here, and then one for T1. So the torque of the dude, right? Again, just like everything else, first of all, we know that we're going to write, did I write L in there? We know that we're going to use this torque equation for each one of the forces we're looking for. So we can use that as a guide. It's very, very important that we use that as a guide in order to make things. So we know that sine's the first important thing. So we put our pencil on the plank, right, or on the surface of the thing with the forces being applied to it, hold it at the axis of rotation, apply the force. So we're looking at the force of the dude, we apply it, we know it's going to do clockwise, which is negative. That's what I do. This is another tool. I didn't do it over here because it would get too messy, but you can do that. You can put the signs next to the thing so that you know what signs these are going to be. So mg is negative because of the way it spins. So minus, and then the force is m1g because I'm calling the dude 1. Right? This is MD, but I should probably also put M1, and this is M2. Okay? So M1G is the same, and then R1 I have written right here, which is also the same as L1, but R1 is 1 meter, which is right there. So there's everything there. Again, the force is MG1, and then R is R1. The next thing I have is, and I know I have these swapped, it's up to you. In fact, let's just R1, M1G, let's just do that, because that's how we really want you writing them right now, because that is a specific way to write them. So yeah, I can see I used L's everywhere where I wanted to not do that. So let me just make sure that you see what I want you to see. I know these aren't written in the right order, but you do want to keep them in this order. I should have written them in this order here, but these values are all just multiplied by each other, so it really doesn't matter. But keep in mind, we want you thinking like this, and they should be written like this down here. It doesn't change anything, okay? It doesn't change anything. All right, so T1, right? I have my first torque. This one's oh, we haven't done them for all of them, right? So then for my next torque, I have it for M2G, right? So I want to, again, put my pencil and apply the force to see what the sign is going to be. This is also negative, so I start with negative, right? We know R is going to be R2, right, which is right here, R2, right? And then M2G, right, is going to be the force. And then our torque for T1, right, is going to be, again, we want to first start by holding it at the axis of rotation, right, and applying the force. So in this case, it would rotate counterclockwise, which is positive. So it's an unsaid positive, we just don't write a sign. And then the R, right, is going to be R3, that total distance, right? And then the force is going to be the tension, T1. I should make sure it says T1. All right? So now we can make our torque equation. I start with the positive 1 just so this equation looks nice. So T1R3, which is right here, minus M1G_R1, which is right there. Again, I know I have the variables flipped down here, but it doesn't matter, okay? But again, it's important to write them like this. And then minus M2G_R2, okay, is equal to 0. So those are all three torques put into the equation there, right? And then, like we said, we're looking for T1. So we want to solve this equation that we have here for T1. T1's right here, right? So it's just as simple as adding M1G_R1 over and M2G_R2 over. So we can see T1R3 is equal to M1G_R1 plus M2G_R2, right? We can see that. Just doing a little step-by-step for you. And then just divide by R3, I call that L there, just divide by R3, and you are done. You have the equation that you need, right? So this stays on top, the M1G_R1 plus M2G_R2 stays on top, and that R3 just comes on the bottom there, and that's T1. So now we have T1. You put the numbers that you have, because you have all those numbers in, and get a value, and then you can plug T1 into here and get T2 when you're done. So there you go, another way to use torque. It's a tool for you to utilize so that you can get really good at this stuff, to understand that physics isn't just to solve for, right? This isn't math class. Torque isn't just to solve for torque. It's like, well, I have this idea of torque that I was given in physics, but all I can use it for is to solve for spinning things. It has nothing to do, even the concept of torque is how efficient a force is going to make something twist, right? But it can just be a tool. You can use it. You can use the math that torque allows you to do, right, in order to get a number, and that's super important, or to get a value or a variable you need. It's super important, because that's what we do in physics. We do this all the time. And so I know I said before, right, math, right, I want you focusing on the physics, the science is a physics class, and it is. And never stop focusing on the science, all right? But you should understand now, and it's starting to become clear now, that the math is equally important, because there's tools within the science of physics that help us solve for these values. So if we understand the concepts and the tools behind the physics, we can see how the math behind those concepts that we understand can help us do things. And torque is the best example. We can understand torque in terms of its concepts and say, hey, I can also use that as a tool to solve for things that I need in other situations if I choose to look at them a little bit differently. So remember, this is a 3-part video. Watch all 3. I want you to compare all 3 of these and tell yourself, okay, this is why Carl solved it this way versus this way, all right? Also, don't forget, you can ask questions in the comments. I will answer them. I'm super proud of you. This is the roughest part, so if you can make it through torque, it's all downhill. All right, so again, I'm not saying it gets easy, but the thought process, this is about as difficult as it gets. When you get into fluids and simple harmonic motion, the ideas are a little bit more intuitive. So thank you so much for watching. I'm super proud of you. Keep up the good work, and I'll see you on the next video.